Hi everyone! So I know we've been talking a little bit about domain and range. So now we're actually going to go into the notation part, and we're going to go over different ways that you can express domain and range. So for this video, we're going to go over set notation. Now with set notation, it's going to have these curly braces at the beginning and at the end. Once you see those curly braces, you're going to know right away set notation. So it pretty much looks like this. So you're going to have your x, this line, and some kind of inequality following that line. So let's go ahead and break it down and see what this means. First of all, when we're talking about sets, it's mainly a list. So we're listing the values for the domain and range of a function. So if we break it down, this x, well, that just means we're looking at the domain. So we can have x for domain, or we can replace it with a y if we're talking about the range. And we say this for all x. That's how we say this part, for all x. So the line that comes after it, you know that, I don't know if you've ever heard that math has its own language. Well, it has its own symbols too, as I know you're sure of. So this line, that's another way of saying such that. So far we have for all x, such that, and we're going to have some kind of inequality. So this inequality, I don't know if you guys have ever seen something like x greater than 12 or negative 2 less than x less than or equal to 5. So that kind of inequality, that's what's going to be in here, depending what your graph is telling you. Okay, so let's go ahead and try our set notation. So we're going to have two examples. One is going to be discrete data, and this one is going to be a continuous function. So as you can tell, the difference is that this is a nice flowy function. So if I trace it with my pen, I do not pick up my pen at all. As opposed to these, I can't trace it because there are no lines, so it jumps around. So this is our discrete data. So let's go ahead and do our set notation. So remember, we're going to start out with our curly braces. But first, let's put our domain, because that's what we're talking about. And with discrete data, we write it a little different. Remember how I said that it's mainly a list that we're making? So with discrete data, that's exactly how we're going to write it, as a list. So first, if I'm going to get my domain, I'm going to start from the negative side and work over to the positive side. And I'm going to list the values on my x-axis that I find a data point. So I'm starting at negative 4. And as I scan over, I see I have 1 point at negative 1. So I'm going to write down negative 1. I'm going to keep scanning. I can see my next point is at 2. And if I keep going, my next one is at 3. My next one is at 4. And my last one is over here at 5. So for the domain, I have listed all the values that I can find a data point on. So we're going to do the same exact thing for a range. So I'm going to put an arv because we're looking for the range. And I'm going to start and end with curly braces. But this time, I'm going to start on the y-axis because it's my range. So I'm going to start from the negative, and I'm going to do the same thing. I'm going to scan up to see there's my first point at negative 3. I keep scanning. My next point is at negative 2. On my y-axis, my next point is at negative 1. And then I keep going. My next point is add 2. And my last one is all the way up here at 5. So that is the set notation for my domain and range with discrete data. So let's go ahead and see what it looks like with a continuous function. So I'm going to start it out the same way. I'm going to look for my domain first. I'm going to write my curly braces. And since this is a continuous function, I can go ahead and start with for all x such that, and I'm going to have some kind of inequality here. So looking at my domain, I know that my domain is going to start at -2. And if I see this arrow, that means it's going to go on forever, right? So then I can put that x is greater than or equal to, because I have a closed circle, -2. Now for my range, I'm going to do the same thing. So I'm going to start out with a curly brace. And since it's continuous, I'm going to put a y. So for all y, such that, and I'm going to scan for my range. So working up, I see my range starts at -1. And the same thing, it's going to go on forever because of that arrow. So I'm going to put x is greater than, or y. Y is greater than or equal to -1. And that is set notation.